Okay, so today we're talking about solving equations by adding or subtracting. So we will solve equations by using the addition and subtraction properties of equality and translate verbal sentences into equations. So this first part says Kareem wants to determine how much his dog weighs. When he weighs himself, he weighs 120 pounds. When he and his dog are both on the scale, they weigh 168 pounds. So A says to write an addition sentence that relates Kareem's weight and his dog's weight to the total weight. Well, we know that his weight is 120 pounds. And we know that the weight of the dog and him together are both 168 pounds. What we don't know is how much the dog weighs. So we could say let X stand for the dog, and it would be 120 plus X equals 168 would be our addition sentence. Now, B says how much does Kareem's dogs weigh? Well, we could simply subtract the 120 from 168, and we would get 48 pounds. Okay? All right. And that's kind of what we're going to use, or what we're going to look at today, is how we would solve these types of problems. So, solve equations by adding. So, a mathematical sentence that contains an equal sign showing that two expressions are equal is called an equation. You can write the equation 120 plus X equals 168 to model the situation. A value for the variable that makes an equation true is called a solution. So for example, if I just plugged in 40 for X, I would get 160, which does not equal 168, so that would be false. But if I solve this and I get 48 and I plug 48 in for 120 plus 48 is 168. So therefore 48 would be the solution. Okay? So 48 would be the solution. The process of finding a solution is called solving the equation. All right. So you can use inverse operations to solve an equation. Inverse operations undo each other. For example, to undo the subtraction of 5 in the equation of y minus 5 equals 10, you could add 5 to each side of the operation. So let's take a look at what that looks like. So if you add the same number to each side of an equation, the two sides remain equal. So let's take a look at an example. 4 equals 4. If I add 9 to both sides, they're still equal. 13 equals 13. So whatever I do to one side of the equal sign, I must do to the other side of the equal sign. So for example, if we're looking at the y minus 5 example, if I add 5 to both sides, I get y equals 15. Okay? It's still equal, because what the left side would equal would be the same as the right side. In other words, y equals 15, or 15 would equal 15. Okay? Equivalent expressions are equations that have the same solution. Because the equation of y minus 5 equals 10 and y equals 15 have the same solution of 15, they are equivalent equations. All right. So let's look at that in practice. So this says to solve the equation, so that's the first part. Then we are to check the solution, that would be the second part. And then to graph it on a number line would be the third part. So we have 3 parts to a question like this, so make sure that you're always reading the instructions to find out what it is you're supposed to do. So if we have x minus 2 equals 6, the first thing we want to do is, this is subtraction. So to undo subtraction, we would do the opposite operation, which is addition. So we add 2 to both sides of the equal sign. And minus 2, and then we add 2 would be 0. And 6, and we add 2 to that would be 8. So x minus 0 would be the same thing as just saying x. So x equals 8. So that's part 1 of the problem. Then to check it, we simply take our solution of 8 and plug it in for the variable x, which is what is done here. So 8 minus 6 should equal 2. And 8 minus 2 should equal 6. 8 minus 2 does equal 6, so 6 equals 6. That's the second answer. We checked it. And then we could draw a number line, put 8, which is our solution, on the number line, and this would be the third part. So now we answered all three. So let's see what that looks like. So if I have negative 13.9 equals n minus 9.7, again, to undo subtraction, you would have to use addition. So we add 9.7 to both sides. Remember, when you add or subtract decimals, you keep your decimals lined up. Well, negative 9.7 plus 9.7 is 0, so that simply leaves me with n. And then negative 13.9 plus 9.7, they're opposite signs. One's positive, one's negative. So I subtract and keep the sign of the larger absolute value. So I would subtract these two, and I get negative 4.2 as my solution. So that's the first part of the answer. Then I would check it. So I'd have negative 13.9 should equal negative 4.2 minus 9.7. Now, when you have two negatives, so negative 4.2 minus 9.7, same sign, add them, keep the sign. So that would be negative 13.9. It checks. That's the. So when I draw my number line, remember I'm using my solution. So it'd be negative 4.0, negative 4.1, negative 4.2, negative 4.3, and it would go right here. Okay? And that would be the third part of the problem. All right. Now, you take a few seconds and complete those two. Again, all three parts. And then come back and see how you did. All right. So in the first one, I would add 5 to both sides. I get x equals 25. Then to check it would be 25 minus 5 should equal 20. And 20 does equal 20, so it checks. And I could go 0, 5, 10, 15, 20, 25, 30, and it goes right here. So there's my three parts. Then on 1B, I would add 6.4 because that's the opposite operation of subtraction. If I do it to one side of the equal sign, I do it to the other side. Minus 6.4 plus 6.4 would be 0, so that leaves me with y. And 10.7 plus 6.4 would be, what? 17.1. Okay? So we could check that, make sure that it works, and see if 17.1 is really the answer. So we would have 17.1 minus 6.4 should equal 10.7. And that would be 10.7 does equal 10.7, so that checks. And then I could go 17, 17.1, 17.2, and that would go right here. All right. Now let's look at subtracting. So some equations can be solved by subtracting the same number from each side. So if you subtract the same number from each side of an equation, the two sides remain equal. So for example, just like addition, if I subtract 3 from both sides, I still end up with answers that equal. So 7 equals 7, subtract 3 from both sides, I get 4 equals 4. Same thing with an equation. If I subtract negative 4 from n plus 4 equals 9 from both sides, I would get n equals 5. Okay? So still the same. If I plug 5 back into n, I would have 9 equals 9. All right. So let's look at this. If we have the same three things we need to find, solve the solution, check the solution, solve the equation, check the solution, and then graph it on a number line. So negative 13 equals x plus 9. So again, the opposite of addition is subtraction. So I subtract 9 and get 0. So that's x equals plus 0, or just x. And then negative 13 minus 9 would be negative 22. So negative 22 equals x. Then I have to check it. So that's the first part. When I check it, I plug in that negative 22 in for x, and I would have negative 22 plus 9, which does equal 13. That's the second part. Then I create my number line, and I plot the negative 22. That's the third part. All right. So if I have m plus 6.7 equals 3.4, the opposite of addition is subtraction, so I subtract 6.7 from both sides. This would be 6.7 minus 6.7 is 0, so that leaves me with m. And then 3.4 minus 6.7, that's opposite signs, so I subtract and keep the sign of the larger absolute value, so that would be negative. And it looks like that would be 3.3. But we can check it and make sure. So negative 3.3 plus 6.7 should equal 3.4. Well, opposite signs, so we subtract again. 7 minus 3 is 4. 6 minus 3 is 3, my decimal point. So therefore, that does check. And then on a number line, I can go negative 3.0, negative 3.1, negative 3.2, negative 3.3, negative 3.4, and it would go here above 3.3. Okay? All right. So you try these two, then come back and see how you did. All right, let's see how you did. So this is a positive 16, so I'm going to subtract 16 from both sides, and that's going to give me z equals negative 2. Now, let's see if we're right. We would have 16 plus a negative 2 should equal 14. 16 minus 2 is 14, so it checks. And then on a number line, negative 1, negative 2, negative 3, it goes right there. All right. Then on 2b, we subtract 0.7 from both sides because it is a positive. So 0.7 minus 0.7 would be 0. That isolates the a, the variable. And then this would give me negative 0.3. Then we need to see if that is correct. So 0.7 plus a negative 0.3 should equal 0.4. And opposite signs, so we subtract. 7 minus 3 is 4, so that is 0.4, which does equal 0.4. And then on a number line, we would have 0, negative 0.1, negative 0.2, negative 0.3, and it would go right there. All right. Then we have a word problem. Jordan deposited $27.50 into his bank account. Now he has a total of $98.50 in his account. Write and solve an addition equation to find how much Jordan had in his account before he made the deposit. So we know the amount he deposited, which is $27. We know the total after the deposit, which is $98.50. We do not know the amount in the account before the deposit. So we let A stand for that. And we end up with $27.50 plus A equals $98.50. So we subtract, because that's the opposite operation as a positive, both sides, and that would give me A equals $71. So that would be my answer, but I will always want to check it. So I plug the 71 into the A, and then make sure that it matches, and it does. Okay? So you try this one and then come back and see how you did. All right, let's see how you did. So Pilar is making digital scrapbooks as gifts for her family. After saving her current work onto a CD, the CD is 5/6 full. So is 5/6 full. If the CD was 1/3 full before she started saving, what was the space, or what was the fraction of space on the CD do the new pages copy? Or occupy, sorry. So 1/3, what it was, plus we'll say C for what she copied, and that should equal again 5/6. Well, same way, just with a fraction. So I subtract 1/3 from both sides. 1/3 minus 1/3 is 0, so that leaves me with a C. Now, 5 6 minus 1/3, we have to get a common denominator first. So that would give me a negative 2 6. Okay? And over here to the side, we'll say 5 6 minus 2 6. 5 minus 2 is 3. 3 over 6 is 3 6. Which I could simplify that down to 1/2. So C equals 1/2. So 1/2 full. Now we want to check that, right? So I could say 1/3 plus 1/2 should equal 5 6. We have to get a common denominator. We know that 1/3 was 2 6 because we already looked that up. So 2 6 plus 1/2. Well, 1/2 times 3 over 3 is going to give me 3 6, which we knew that from before. And 2 plus 3 is 5, and 5 6 does equal 5 6, so it does check. All right, if you got any questions, let me know.